So let us work out the denial of Euclid's first postulate. So for every point P and for every point Q not equal to P, there exists a unique line L that passes through point P and Q. So let's negate this, all pairs of point P and Q, no? That there is the existence of this point P and Q that will not satisfy the postulate. So ano ba yung sinasabi dyan? That every point P and every point Q not equal to P, there exists a unique line that passes through P and Q. So what you see in postulate 1, it involves a conjunction, asserting that P and Q lie on the same line L, and that is unique. So dalawa. So they lie on the same line and L is unique. So in order to deny that conjunction, we are going to follow rule number 5. So the assertion becomes either P and Q do not lie on any line, or they lie on more than one line. So that is the negation of that conjunction. So yung una, so they either P or Q do not lie on any line, or they lie on more than one line. So yun yung a way on how to negate that statement na P and Q lie on the same line. So thus we can say that there are 2 points P and Q that either do not lie on any line or lie on more than one line. So that's how we're going to negate Euclid's first postulate. So ito yun. Yan yung sinasabing conjunction kanina. And we are trying to negate this statement. So let's proceed with implications. So you have heard a lot about implications before. Once you have heard the if P then Q, then we are referring to implication. So formally, here's the description or definition of implication. In logic, it means a relationship between two propositions in which the second is a logical consequence of the first. So in most systems of formal logic, a broader relationship called material implication is employed. So this is read as if P then Q. So we are familiar with that. So we also have this concept of modus ponens in logic. So here's the rule of detachment. No. So others, they call it also the rule of affirmation if we are talking about the validity of the statement. So the modus ponens that we have here is the rule of inference that is used to draw logical conclusions, which states that if P is true and if P implies Q, then Q is true. So we are just simply referring to the validity of the statement of P. So kung totoo si P, then if P then Q is also true. So anyway, but in our topic for today, we are not really into the discussion of the truth table or the validity of this statement. So we are just having a run through of these different logic rules. So let's have logic rule number 8. If P then Q and P are steps in a proof, then Q is a justifiable step. So sinasabi dyan, kung totoo si P dun sa nakita natin sa steps ni proof, then mako-conclude natin si Q. This rule is almost a definition of what we mean by implication. So here's, for example, postulate number 4. If angle A and angle B are right angles, then angle A is congruent to angle B. But please don't be confused with the converse of this conditional statement. Iba naman yung Q then P. So, ang usapan lang natin dito sa rule number 8, we are referring to if P then Q. If P is true, then we can make use of the implication for Q. No? So, rule number 8 allows us to assert their congruence as a step in the proof. So, along the proof, after having the condition na if angle A and angle B are right angles. So, upon doing the steps in our proof, then we can now conclude, no, after showing yung mga without any violation na kung ito yung condition natin ay si P, then we can say our conclusion Q. So, if you still remember our discussion in the methods of proof, so meron tayong conditional statement na if P then Q, tapos meron tayong converse ng implication na yan, which is if Q then P. So, again, hindi necessary na kapag totoo si if P then Q, ay totoo rin si if Q then P. So, hindi natin pwedeng sabihin dito, if Q, that is if angle A is congruent to angle B, pag sinabi, hindi natin pwedeng masabing totoo na if angle A is congruent to angle B, then angle A and angle B are right angles. So, hindi yan necessarily true. Okay? So, however, it may sometimes happen that both conditional statement and its converse are valid, usually kapag definition yan, no? So, kapag nangyayari yon, nagkakaroon tayo ng logically equivalent, no? Sinasabi natin P is logically equivalent to Q, kaya nandiyan yung if and only if, yung biconditional statement natin. So, anyway, let's proceed to the next concept, that is tautology. Tautology is an expression or phrase that says the same thing twice, just in a different way. So the statement is always true because one half of the or construction must be true. So, sa tautology in mathematics and in logic is a compound statement. So, meron siyang premise and conclusion that always produces truth, no matter kung yung individual parts niya. Regardless kung ano yung sinasabi ng individual parts, the result is a true statement. So, again, in tautology, so, a tautology is always true. So, example, no? Either it will rain tomorrow or it won't rain. Diba? So, regardless. No? Pwedeng umulan, pwedeng hindi. Isa sa mga yun, totoo. Bill will win the election or he will not win the election. So, posibleng maging totoo din yan. Okay? She is brave or she is not brave. Isa sa mga yan, totoo. Okay, so yun yung sinasabi natin. Okay, so let's have the logic rule number 9. So, dun muna tayo sa letter A. Sa letter A, if you're going to look into, by the way, all of these three are tautology. So, regardless kung ano ang form ni P, Q, and R, here, they are always true. So, the first one is tawag dyan, hypothetical syllogism. So, yung the sentence na if P then Q and if Q then R implies that P then R. So, ito yung transitivity na meron tayo. So, it is an example of tautology, a sentence which is always true regardless kung ano ang truth truthfulness regarding P, Q, and R. So, yung letter B naman has something to do with simplification. So, the first one is P and Q. So, we are having this conjunction of P and Q, then P. Sabi niya, P and Q, then P. So, it's the same as P and Q, then Q. So, yan yung simplification natin. So, then letter C is an example of contraposition. No? It is closely related strategy to prove that P implies Q. Minsan, ginagawa natin to prove that P implies Q, ginagamit natin yung contrapositive na not Q, then not P. So, hence, the strategy is assume that B is false and prove that this implies that A is also false. So, pag napakita mong false si B, then false na rin si A. So, yun yung way on how to prove this, no? A certain statement kapag ginamitan mo siya ng contraposition. Okay. So, I'll be giving you, by the way, handouts to have more readings about logic. So, but we cannot really discuss everything about logic here in this section. So, what we are just doing is that we're having a run through again, no, about these logic rules. So, ayan. So, we're down to the last two. And the last two has something to do with not so, famous ways on proof. So, as much as possible, kung pwedeng iwasan, iniiwasan eh. Pero, minsan wala tayong ibang way kundi pakita yung mga to. So, law of excluded middle and proof by cases. So, dun tayo muna sa law of excluded middle. It is also the proof by cases. Pero, anong meron sa law of excluded middle? So, sinasabi dito, for every statement about P, so, yung disjunction natin, P or not P, is a valid step in a proof. So, ang sinasabi dyan, we are actually having these cases. Sabi ko nga cases, yung mga dalawang to. Ipapakita mo si P or yung not P. So, kung ito yung pangyayari, parang assume mo din yung P. Tapos, ipapakita mo din yung not P. So, given, let's have this example. Given point P and line L, we may assert that either P lies on L or it does not. So, dalawang pwede natin pakita. It's either na it will lie on P or it will not lie. It's either P will lie on L or P will not lie on L. So, dalawang bagay. Parang yung kanina, it's either uulan ngayon or hindi uulan ngayon. Isa sa mga yon totoo. So, yun yung sinasabing law of excluded middle. Wala tayong neutral dito. Kaya excluded middle, wala yung neutral portion. So, it's either mangyayari ito or yung isa. So, ganun yun. So, hindi pwedeng parehong mangyayari. Ayun. So, if you're going to make use this as a step in your proof, what you're going to do is to break the proof into cases, giving an argument under the case assuming P, and another argument under the assumption yung of not P. So, merong isang case, example, case 1, that is P, assume P, no? Then, case 2, assume not P. So, yung both argument must be given or else the proof is incomplete. So, minsan kasi pinapakita natin yung isang side lang, pero hindi pa yon enough. So, kaya minsan kailangan pakita mo yung dalawang cases. Okay, yung template niya, ganito ang itsura. So, yung case 1, you assume that a certain number is equal to 0, for example. Tapos, sa another case mo, assume mo na A is not equal to 0. So, mayroon kang dalawang cases dyan. So, along the way, may pinapakita kang proof, tapos may conclusion ka doon. Then, you will make another case, gagawa ka ng ibang assumption, yung not P naman doon. So, if one or two possibilities must hold, and different proofs are needed to handle the different possibilities, then a proof by cases is called for. So, ayan. So, this is one way. So, I want you to have this. I want you to see page 23 of our references to examine more about the proof by cases. So, sa page 23 ng Greenberg, so, meron dyan yung proving that triangle is an isosceles. So, you have to show the proof in your journal and explain it. So, you can make use of geometry software to try drawing it, no? Construct the images. So, let's continue. So, baka matulong din yung mga susunod na case. This is the last logic rule that we are going to discuss. Ito naman is another variation of proof by cases. So, suppose the disjunction, again, disjunction natin gumagamit ng or, of the statement 1 or statement 2 or statement SN, no, magayan, is already a valid step in the proof. Suppose that the proofs of C are carried out from each of the case assumptions, S1, S2 up to Sn, kung ilan mang cases yan, then C can be concluded as a valid step in the proof. So, yan. So, another, important variation sa ating direct proof is the proof by cases. So, this is needed whenever you need to prove that two or more different hypotheses lead to the same conclusion. And the most common example of this is the hypothesis, no? Whose hypothesis is a disjunction. So, ito yung may or statement. So, ito yung format naman ng template. So, ayan. So, if you have a theorem, P sub 1, or P sub 2, then Q. So, ibig sabihin dito, meron kang isang statement or another statement, tapos conclusion mo ay Q. So, in your proof, you are assuming, no, P sub 1 or P sub 2 as your hypothesis, then you make now your assumption. So, assume mo si P sub 1 is true, then assume mo si P sub 2 is true. So, kung meron pang ibang statement dyan, or P sub 3 or P sub 4, then you continue working on your cases. So, ayan. So, I think mas appropriate dito yung gagawin nyo, pinapagawa ko sa inyo yung looking into the proof by cases ng triangle is an isosceles triangle. So, meron siyang mga cases dyan regarding the regarding the altitude of a triangle, tsaka yung angle bisector. So, you look into the connection of the altitude of a triangle and the angle bisector ng ating triangle, at kung anong relationship ng mga yon. So, we have that in plane geometry, but I want you to look into how you're going to formally prove them by cases. So, for now, that ends, no? Or that concludes our discussion of logic. So, disclaimer lang. A short disclaimer that the discussion may not show all the rules of logic. Those which were discussed should suffice our purposes in this course. So, for now, that will be all. See you on the next video.